For decades, we've looked up at the night sky, admired the black void of space, and dreamed of leaving Earth behind for a fresh start. Astronomers frequently tease us with listings for the galaxy's premium real estate. Exoplanet targets like Proxima Centauri b or the 7 rocky worlds of the TRAPPIST-1 system are often pitched as highly sought-after destinations for humanity's next chapter. This diagram maps the habitable zone. To earn that label, a planet needs a rocky surface and to orbit inside this highlighted band, where liquid water can pool. But sitting here only means a cup of water won't immediately flash boil or freeze into solid ice. It absolutely does not guarantee that the planet is safe for living organisms. That habitable label is an astronomical bait and switch, using math to mask a horrifying environmental reality. Most of these so-called habitable worlds orbit red dwarf stars. Because these stars are relatively cool and dim, a planet has to orbit extremely close to its sun just to receive any warmth. That tight embrace comes with a severe physical consequence, a phenomenon called tidal locking. This animation shows how it works. Instead of spinning freely like Earth, the immense gravitational pull of the nearby star forces the planet's rotation to synchronize with its orbit. One hemisphere is permanently locked in place, staring directly at the host star, while the other faces out into deep space. On the permanent day side, the host star constantly bakes the surface. Temperatures can soar to 2,500 degrees Celsius, hot enough to melt rocks and vaporize metals like iron and titanium. Meanwhile, the night side is shrouded in eternal darkness, trapped in an absolute deep freeze hundreds of degrees below zero. Separating these two extremes is the terminator line, a fixed, permanent sunset boundary where the scorching light meets the freezing dark. Your basic real estate choice on a tidally locked world boils down to immediate incineration on the front porch or eternal freezing in the backyard. That drastic temperature difference sets up an unavoidable collision in the atmosphere. The boiling dayside air rapidly expands and clashes directly against the sinking, freezing air of the night side. These massive thermal extremes trigger a violent thermodynamic balancing act as the planet desperately tries to distribute the heat. The result is a planetary weather system driven by continuous supersonic global gales that whip horizontally across the surface without ever stopping. On planets like HD 189733b, winds tear through the atmosphere at over 5,000 miles per hour, carrying jagged droplets of liquid glass. On WASP 76b, the storms drag vaporized iron from the day side to the night side, where it condenses and falls as heavy metallic rain. On a tidally locked world, the atmosphere functions purely as an aggressive heat transfer engine. It makes the surface completely unsurvivable. Even if you could survive the weather, you still have to deal with the local neighborhood watch. Many of these planets orbit young red dwarfs, like the star AU Microscopy. These dim stars are highly unstable and prone to chaotic, massive flaring events. These eruptions launch intense blasts of X-rays and extreme ultraviolet radiation directly at the tightly orbiting planets. This animation illustrates the first major consequence. The sheer force of the incoming high-energy radiation physically strips away the planet's atmospheric envelope, blowing its protective gases out into the void. Without that atmosphere to shield the ground, the rocky surface is subjected to frequent, complete biological sterilization. So, even if an astronaut somehow built a shelter strong enough to withstand the supersonic iron winds and magma melting temperatures, the host star would ultimately just microwave them inside it. To recap, the top-tier amenities of our best exoplanet candidates include perpetual darkness, raging magma oceans, horizontal supersonic glass rain, and daily sterilizing radiation baths. Scientists continue to use the term habitable because for them, it is a rigid mathematical metric of orbital distance. It is not a measure of human comfort. These alien worlds reveal the true nature of planetary meteorology. Weather is universally just a thermodynamic gradient moving heat around. It will use whatever materials are present to get the job done, whether that's gentle water vapor or heavy liquid iron. Studying these violently hostile environments highlights the incredibly rare, stable, and lucky environment we occupy right here in our own solar system. It's time to cancel the cosmic moving ban. Earth is the only property where the environment isn't actively trying to eradicate you, so we are staying home.